بسم الله الرحمن الرحيم رب زدني علما.
So what we'll do is we'll try to go ahead with the same OSPF default root lab based on the slightly a real-time setup kind of thing. Like if you remember, I discussed that we will be using dynamic routing between the head office and the branch offices, which means I'll be running OSPF area 0 between the router 1 and the router 2. And from the head office router, we will be configuring the default route, which is going to say that any unknown traffic will be sent to the ISP. And from the ISP, there will be a static route. So I'm not running OSPF. I'll remove this OSPF. And because in our lab, I said that is an alternative, we will configure a static route. Okay. So we'll configure a static route for the public IP. So you can use any public IP, let's say anything like a specific static route. Let's say I'm going to use the same 2 dot public IP, 2 dot, 2 dot, 2 dot from this same subnet. Okay. Let's say, let me just use some random IP 2.1.1.1 or 2.0.0.1 or whatever the IP I'm going to use. Okay. So that will be the public IP. I'll try to use the same subnet just to avoid any kind of other routing issues. So that will be the public IP I'll be using for translation. And additionally, on the top of this, I'm going to configure the NAT. Okay. So the NAT is again configured. Now, there are two ways to do the NAT. Either I can translate all your private IP addresses will be translated to the public IP. And that public IP can be 2.0.0.1, or you can also use the exit interface. If you just go back to the NAT concepts, we can also translate to this 2.2.2.1 also. That can be the public IP also, which means in that case, I don't need to write the static route. Okay. So we'll try to do that. And at the same time, we'll also advertise the default route and do the verification part. So the first thing, if you go back to the previous lab, we already configured OSPF between router 1, router 2 and router 3. I'll remove that one. The 2 dot network, which I'm advertising between them, I will remove that. And the same thing, I'll do it on the router 3, because normally you never run OSPF between the head office and the ISP, because you run BGP, that is another case. But normally you don't run dynamic routing because you never exchange any routes with the service provider, because the service provider is supposed to provide you the internet access. So you already have the default route. So what I'll do is I'll go to the router 2 and I'm going to do the NAT translations. How to write the NAT translations? We need to write all your private addresses in one network. Let's say private address, PR address, that's a private address. We are going to say permit. Now, what are the networks I have here? The private network starts with 10. Most likely this is 10 and 20, right? 20 dot network and even 1 dot network. Assume these are not exactly private, but as per my IP addressing, we assume they are the private IP addresses which are used in my LAN, and they need to get translated to the public IPs. Okay. So we'll say permit 10 dot network with /20/8 I'm using. 20 dot network, and then there is 1 dot network. Anyway, I'm not initiating any traffic from one, but that's okay. So define all your private addresses in one statement. And then we have to say IPNAT inside source list. List is your access list. We have to say access list is this. And then we have to say interface overload. Interface, what is the interface I'm using? S1/1 and overload. So which means I'm saying that all these private addresses, whatever I defined inside this, has to get translated to the public IP, whatever is present on the outside interface. And then we have to give inside outside command. NAT configuration also includes inside outside. So S1/1 is outside interface facing towards ISP, and all my interfaces facing towards my LAN. Remember, all your interfaces are facing within the LAN. Like in my case, this is going to be my outside interface, which translates to public IP. And this is going to be my inside interface, and this is going to be my inside interface from where I get the private IPs. So if you have more branch offices, let's say connected, all these interfaces will be inside, because you expect all the private IPs coming from these branches. So you have to configure all them in the as an inside interface. In my example, the LAN interface as well as the WAN interface, also inside interface, because from this interface, my branch office will be sending the private addresses. So this way we are done with the NAT configurations. Normally, if I'm using another public IP, I should have a static route, but that's not required here because I'm translating with the exit interface. That's going to work for me. And what else we need to do? We need to make sure that we do have reachability to these IPs based on the default route from the router 2. I'm expecting that we should have the route. Now, there is one more thing. If you remember, we already did this. There is a default information originate already configured, which means whatever the S asterisk route is already advertised as O asterisk or OE2 asterisk route. So now if routing is perfectly configured, then I'm expecting that should work. You can see if I try to ping, the ping is working. Now why it is working? Because now if you try to see here, even when I try to initiate a traffic from LAN, let's say I'm going to initiate a traffic from the LAN, it's working, right? So you can just repeat some packets. Now if you go and verify router 2, where I have a NAT configured, NAT translations, you can see when I'm initiating a traffic from the router 1, this is the source address. When I'm initiating the traffic from 10.1.1.1, the LAN interface, it is using the public IP. So the public IP is the exit interface, which means just like in the real case, when you're sending the traffic from 10.1.1.1 and you're trying to reach 13.0.0.1, which is somewhere on the internet, as the router 1 do not have any information. Let's see how the routing exactly works in this case. So the router 1 simply says, I don't know where is 13. I don't see any route in my routing table, but I'm receiving a default route from the head office. And my job is to make sure that I'm going to send this packet to the head office. Means from wherever it is coming, from 1.1.1.2. Maybe you may have 5-6 routers in between, of course. Okay. So it will ensure that it reaches the head office, and the job to reach the head office is the protocol job. So whose job is to make sure that the packet reaches the head office? OSPF will take care, because that is what OSPF is doing in your network. And why it will take you to the head office? Because head office is advertising the default route. And that's the reason I'm receiving the default route from the head office. So it will reach the head office. Now, once it reaches the head office, now the head office will say, I want to go to 13.network. The head office also say, I don't know where is 13. You can see any route. I don't know where is 13, but I have a default route, a static default route now this time. I have a static default route, which is configured, saying that any unknown packet, simply send it to the ISP. So from there, it reaches the router 3. Now the router 3 will forward. Router 3 means it reaches the ISP. And in the real scenarios, the Yahoo server doesn't reside here. Yahoo server is somewhere on the internet. It will reach based on the BGP protocol. That's not the concept right now. You will see them in the BGP concepts. But your packet reaches here. Once it reaches here now, it reaches the Yahoo server and you'll get the packet back. But there is one thing exactly happening when the packet is going here. The source address is getting translated to 2.2.2.1 and the destination address remains the same. And this is happening because of the NAT. Because as the packet leaves this interface, there is a NAT configured, which is going to tell that the source address is 2.2.2.1 and the destination, because the public IP, whatever we used in the NAT, and reaches the router 3. And the router 3 is going to return back the traffic. When it is returning back, the source address will be 13.0.0.1 and destination will be 2.2.2.1. Now this router knows where is 2.2.1. because it knows it is connected, or it can be through static routing, or it can be through BGP. So that is the job of the ISP. Okay. So, but here we are trying to understand the logic, the routing logic, how it works. Because at the end, if you're working for a service provider or if you are providing the service to some customer, you should understand the process. So it reaches back again, and once it returns back, again, it will change the destination address to 10.1.1.1, which means now from here onwards, again, the packet reaches 10.1.1.1 based on the private IP. Because the NAT says you're coming from outside interface, as you're going towards the inside interface, you have to go with the private IP, as it is the same private IP what is present. And this router knows, this head office router knows where is 10.1.1.1 through the OSPF. Already it knows how to reach out. Okay. So this is how the routing is going to work in the real scenario, where you will have a mix of NAT configured on the edge router. And you don't configure NAT on every router, the edge router, that is your head office. And of course, as I said, you will not have just one ISP connection, you will have two ISP connections. Just for the sake of simplicity, I'm using ISP1, only one ISP. But technically, you will have two ISP connections because redundancy is very important. So you will get the default routes from both, and OSPF will be advertising both the default routes, and it will select anyone because at the end, it will reach the head office, right? And depending upon the administrative distance, whatever you configure, it will use any one. These things we already covered in the floating default routes. Okay, so the idea here is to implement and verify the advertising of the default routes, how it works with NAT implementation, similar to production network by using one single ISP connection.